because I start with 0, 0, 1, 0, 1, 1, 0, 1. Why does this help me? This is kind of cool. So first, this is a sequence of 1s and 0s, right? It's an ugly sequence of 1s and 0s, but it's a sequence of 1s and 0s. So it's on my list somewhere. That was the whole point, right? That I listed everything. I can't leave anything out. Without looking at the first number, could it be the first sequence on my list? Okay, it's obviously not, because right, the first sequence on my list goes 0, 0, 1. This goes 1, 1, 0. They're not the same. But is there even a chance that it could have been the first number on my list? Actually, no. The first digit wouldn't be the same, right? The first digit of this thing is different from the first digit of this, which is just the first digit of the first number, right? So this can't be the first sequence on my series, right? Sequence on my table. Could it be the second sequence on my table? The second digit is different from the second digit on the diagonal, which is just the second digit of the second sequence, right? So it can't be the second sequence on my table. It can't be the third, because the third digit is different from the third. It can't be the fourth, because the fourth digit is different. It can't be the nth, because the nth digit is different from the nth. This can't be on my table at all. But I assume that I somehow found a magical way to list all possible sequences of zeros and ones. Obviously, that can't happen. The world explodes, cats rotate at speeds greater than the speed of light. You ever heard the cat toast machine? No. Oh, toast always lands butter side down. Cats always land on their feet. Take a piece of toast butter side up to the back of a cat and drop it from high height. It will rotate very rapidly before hitting the ground because the feet of the cat have to land, but the butter on the toast has to land, so it has to land both upside down and right side up. And if you attach it to a turbine, you can power it steady for a week until the cat sets itself on fire due to air resistance.
Schrodinger's breakfast.
Exactly. So this is really cool for at least two reasons.
Wait,
Yeah.
where did D come from?
I took things down the diagonal.
Or sorry, D.
I changed everything in D.
That's
The reverse.
Yep.
from 0 to 1 and 1 to 0.
So
Oh, I see.
formally, D tilde of n. This, by the way, I don't, again, know who came up with this because it's stupid, but this means the nth digit of D. Don't, or in this case, D tilde. Don't use this in your homeworks because only logicians use this. I'm not really sure why we use it. It's a stupid notation, but we do. I define that to be D of n, whatever that's not, right? And so that gives me something that can't be the first because it's not on the first, can't be second. But these sequences are just sets, right? Given a sequence, I get a set out of it. In this case, my set would have, it would contain 0, 1, 2, 4, maybe some other stuff. I can't tell what's past the dot, dot, dot. So there are strictly more sets of natural numbers than natural numbers. This is not necessarily that surprising. It only makes sense as a surprising theorem if you remember that when it was proved, it was common knowledge that it wasn't true. Because every single time people had come up with examples of infinite sets, they'd been the same. So this isn't really startling anymore because nobody talks about how all infinite sets are the same, because they aren't, and we know that. But it used to be surprising. It's also surprising, at least to me, because we can actually prove things about infinity without going mad. Although, for the record, nobody think about this too hard because the guy who came up with this died in an insane asylum, and the guy who followed him, who developed all his work and turned into modern set theory, died behind a refrigerator clutching a frozen chicken, having started. So, I'm just saying, there's a yeah.
Please dot dot dot.
What is dot dot dot? I will tell you after. There is a story involving dot dot dot. Actually, a very funny one that is basically why mathematicians hate physicists or else vice versa. I'm not really sure which.
There you go. I think that.
Yeah.
Could it be a mutual circle of hatred?
Yeah, between mathematicians and physicists.
Oh, yes, certainly.
So, actually, I would like to mention that not all mathematicians die who study infinity. There's a
Some
guy
of
named
them run away to become
pretty sure
fly
they all
fishermen
die
in Belize.
there's a guy named Saharon Sheila, who is currently the most famous set theorist around, probably the most brilliant since Gödel. He's perfectly alive. He's published only 500 papers. He's brilliant. He's a fully functional human being. And there's merely the one problem that nobody
Fully functional human
Yeah.
being.
nobody else can understand a single one of his proofs. Pretty much.
How do we know they're
Awkward.
true?
Well, you can with months of effort. Each of his papers, he writes a paper a month, and each paper takes about 3 months to be published because the referees are like, what the fuck is this? Example, there is no meaning to the following set of symbols that I can tell you because I don't know it. 2 olive null less than olive omega 4 assuming GCH.
Oh.
No, not assuming that. Assuming PCF. This makes no sense. This makes absolutely no sense to anybody. It is true. Nobody knows why.
PCS are private contracting firms.
Actually, this creates a possible co-analogy, but yes. So, okay, maybe I shouldn't be studying infinity, but I'm already crazy, so who the hell cares? So, I promise this will make sense as to why I covered it in about a minute. This is actually useful. For now, all
I'm just watching
Yeah.
it.
all that I need is the following. Some infinite sets are no bigger than the natural numbers. Some are. The sets that are infinite, that are no bigger than the natural numbers, are called countable, because I can count them, right? I can count the even numbers. I can give each even number a natural number and make it work. I cannot count the sets of natural numbers. An interesting exercise, do you think I can count the rational numbers? This one's cool. You know the answer, so shut up.
Yeah.
I'd go with yeah.
It turns out you can. I will sketch briefly how. It's not very important, but it's really, really
How
cool.
many are
Well, there's obviously
there? Oh.
So basically, here's the picture you draw. You put all the natural numbers in a list like this, in a big table.
Oh, they're n by n.
Yep. And then to count them, I do this. This is the first one, second one, third one, fourth one, fifth one, sixth one, seventh one, eighth one, ninth one, 10th one, and I just zigzag through the entire list.
That
And
makes
it
no
works.
sense.
It doesn't, but it actually works. It does actually work, it does not make any sense.
It does when you sit with it for a while.
Yeah, it does.
But we didn't, but have we come up with a number? Like besides Aleph not?
Aleph not is the size of infinity that it is.
Oh.
They're all the same. There are as many natural numbers as there are rational numbers. This is weird stuff.
That's what capital means.
So,
Gotcha.
now I can stop writing and work for pretty much the rest of the point because I can't really leave this crap down. It makes no sense to anybody. Random bit of history of math. 1905. Formal logic has roughly just been invented. We know what the hell we're doing, but we don't know what we want to be doing. We're still on a quest for a system of logic that works. We've learned sort of how to make formal arguments. We've learned what a proof is fully. There actually were some issues at around then about what constituted a proof. Interesting history of math regression, but it's not entirely relevant. Point is, people wanted a system of logic. There's a crazy guy named Hilbert who thought that if you could get the right system of logic, you could prove everything with it. And you could disprove everything, and you could be like, oh man, I just totally owned math with a machine. He's wrong, and he died alone and unloved, I think. Though I'm not really sure. But I don't think so. He didn't die happily, I thought.
Most
I don't know.
mathematicians
I'll look it. There's a decent chance that Hilbert died alone
Sorry.
and unloved.
You're
However,
gonna give up your mathematicianness for Christ.
However-
And then you'll become his bride.
And you'll
He at least deserved to die.
You can't gain very credit.
Julia,
You should be able to. You can't gain very credit.
Yar. Yar.
A boy.
So first of all, first of all, it is an interesting topic whether you can gay marriage justified in a spiritual manner. Second of all, we're not going to stab him with a pen, getting on with logic. There were originally two ideas with logic. There was the idea that it would capture mathematics, and it would also capture human reasoning to some extent. That we could do mathematically what we could also have what Leibniz called the, I'm forgetting the Latin, the calculus of concepts, the calculus of ideas. Other authors called this the calculus universalis, but that wasn't Leibniz's term for it, I forget what his was. That idea sort of died hard in the following way. What we came up with was first order logic. It's a nice system. It looks like this. This is pretty much the one remaining thing